I'm Diego.
And I'm Alex.
And this is our fish project.
This is a fish. That's our shape.
Our 3D model is a fish.
Yep.
It's this one.
This one right here. We use 2 sine waves. So that's 1 sine wave right there. And then the second sine wave right there. And then we got 1 absolute value.
That's negative.
Negative.
Mm-hmm.
Right there.
Actually, in this case it'd be positive because we flipped it. But that's okay. It's an absolute value.
Absolute value goes out like that. And then we got a line right there at y equals negative 1.2.
Yep.
And it creates a fish.
Oh man. Let's just hold it with our phone.
Alright, we are back.
And for our fish, we used 90 slices to create the entire fish. We used 43 for the body and 47 for the tail.
That's 90 total.
That is 90 total.
And we used rainbow paper. So we got rainbow paper for the head and we got polka dot paper for the tail. We didn't really think that polka dot paper through because from, I'm sure where you're standing, it just looks like white
piece of paper.
But it's not, I promise. There's white polka dots. There's polka dots all over it.
And the polka dots are also rainbow.
They are also rainbow polka dots. And we had a bunch of extra rainbow paper. So actually we only had 1 extra piece of rainbow paper. So we made some little designs on it.
Not to leave it empty, you know?
Yeah, we wanted to make it look pretty. You should take that into account when you're grading our paper. Okay? Nice pretty hearts and little fishies. I cut those fishies out. He cut those hearts out.
What is up? For our calculations, we multiplied pi over 8 times the radius squared times the gap in between each slice, which for us was 0.23. And we did that 43 times for the body, right here, this chart. And we did it 47 times for the tail.
47. 43. Good morning.
Good morning.
So, for our integral, right here, our first function f of x is 2 sine 3x over 5. That is for this sine wave, the top one. Okay. G of x equals negative 2 sine 3x over 5, which is the bottom sine wave. Now, we cut it off after it hit a certain point, after it hit where they intersect, which is at 5 pi over 3. They intersect at 5 pi over 3 right here. Oh my god, it just got hot outside. So now we integrate it. We have to subtract the top from the bottom. So it's 2 sine 3x over 5 minus negative 2 sine 3x over 5. Integrate that from 0 to 5 pi over 3 times pi over 2 squared. So then you work this out. Okay, you put these together as 2 sine 3x over 5 squared to pi over 2. Then keep working it out, you know, right here. Then this is where some fantastic happens right here. Okay, we've integrated it. It's 2x minus 5 sine 6x or 6x over 5 over 3. Then the volume, oh my gosh, it's falling. The volume equals pi over 2, 10 pi over 3. You multiply that together, it's 5 pi squared over 3. And the volume is approximately 16.449 for the body. There's our work for the body. Unlike our body, which was done in terms of dx, our tail was done in terms of dy. So our formula was f of y equals negative y, absolute value of y over 2. G of y is negative 1.2. Oh my. So our formula is going to be it's going to be 2 times pi over 8 times the integral of 0 to 2.4 of negative 1.2 from right there minus negative absolute value of y over 2 squared, quantity squared, dy. Now we're taking it from 0 to 2.4 because 0 is here and 2.4 is here, and then we're multiplying it times 2 to get, because they're equal to each other, so it's just, we're going to do this one times 2. All right, now we're doing v equals pi over 4 times 144 over 125, which is what this equals. Okay, And then V equals 36 pi over 125, which is approximately 0.905. So that means the volume of the tail is 0.905 exactly.
All right, and so now for the percent error, we use the formula that was the absolute value of the approximate minus the exact over the exact times 100, which here is this one minus this one over this times 100, which is 0.02.
Yes.
So a 2% error.
And we get the total by adding the volumes of all of our Raymond sums together. Now we gotta do the same for that side.
Oh. And then for here, the same thing. This minus this over this is equal to our percent error.
So for our tail, we got a percent error of 1.19, and for our body, we got a percent error of 2.02%. Was it recording?
Yeah.
What is up, Mr.
Hi.
Montez?
Hello.
We're gonna talk to you about what we're proud of now in our project.
We like the colors. It's really colorful, and
It's all good.
and I don't like to make the board, seem boring. So it's not boring anymore with all these colors.
It is not. See, we got pink. We got pink. We got rainbow, and we got cross sections fish. Now, another thing that I'm particularly proud of is when we were doing our project, we realized that we're failing because these things were falling over, and that wasn't very good for our presentation. So I added these little hot glue gloops into the middle right there.
The gloop method.
The gloop method to keep them a little separated, 2.5 inches exactly, or 3 inches exactly, or squares, 2.3 squared. You know what I'm saying? You know what I'm saying, Mr. Montez. 2.3 exactly, and now it looks pretty-ish. See how it like all stays together now? That's particularly what we're proud of. Speaking of what we're most proud of, that also happens to be what was the most challenging, because for a while we could not think of the gloop method, but because we thought of it, now our project doesn't look horrible.
Some good advice that we have for students who might do this project in the future. You see this foam right here? This foam down here? This weak foam, cheap foam, because we are not loved by our parents. We're not funded. This was 99 cents a pop.
And they got it on discount.
And we got it on discount, 50% off. Get some good foam, kids.
Yeah, like thick foam.
Thick foam that will not fall over.
Yeah.
And if you don't have money and your parents don't love you like us, then use the gloop method. The gloop method saved our project.
And now we're gonna get an A. Thank you for watching!